In this video, we're going to talk about how to find all the solutions of the trig equation tangent of 4x minus the square root of 3 is equal to 0. So this problem presents something interesting because we have a number being multiplied by the x, and this time we have 4x, or in another problem maybe 4 theta or something like that. So that's an interesting challenge. So we'll talk about that in a minute, but there's another interesting challenge, and this is what happens anytime you're talking about tangent, which you'll see in a second also. So our first strategy is to get tangent by itself, or tangent 4x by itself, and we're going to do that by adding the square root of 3 to both sides of this equation. That's going to give us tangent 4x is equal to the square root of 3. And so here's one of the challenges I was mentioning. Tangent on the unit circle, now that we've isolated tangent, we can go to our unit circle. And on the unit circle, tangent is going to be your y value divided by your x value. So anytime we have tangent theta, that's going to be the y value divided by x, because y value is the sine of theta and the x value is the cosine theta. And tangent theta, of course, is sine theta over cosine theta using our quotient identity. And so what we want to know is what types of things y value divided by an x value are going to simplify and turn into the square root of 3, because it's not completely obvious. And when that is going to happen is it's going to be when we have something like, for instance, the square root of 3 over 2 over 1/2. So something, for instance, like a y value of the square root of 3 over 2 and an x value of 1/2, so something like pi over 3, for instance. Also, it would happen in 4 pi over 3, because there we would have the same y value and x value. They would both be negative, and the two negatives would cancel out. And the reason this simplifies to the square root of 3 is because we have two fractions divided by each other, and so what you want to do is you just multiply by the reciprocal of the denominator. And so you get the square root of 3 over 2 multiplied by 2 over 1, and then the 2's are going to cancel on top and bottom, leaving you with the square root of 3 over 1, which is just the square root of 3. And so those are the two locations on the unit circle where the y value divided by the x value, or tangent theta, is going to be equal to the square root of 3. So that's one problem we just have solved by thinking of it that way. We know the two locations where tangent theta or tangent x would be equal to the square root of 3. But the other problem that we mentioned earlier in this video is that we don't just have tangent x, we have tangent 4 times x. And so what we're going to do is we've already figured out that the values or the angles we're looking for, at least with one iteration around between 0 and 2 pi on the unit circle, are pi over 3 and 4 pi over 3. And so what we're going to do, whenever you have a problem or a number being multiplied by the argument, that's what we call the x value there. In this case, it's a 4 multiplied by x. What you do is you set up this equation. Instead of saying theta is equal to our solutions or x is equal to our solutions, you say 4x is equal to our possible solutions that we found on the unit circle. So you just bring that 4 right along with the x. And then you can see, okay, now I see how it's set up. We still need to solve for x, so we're going to divide everything by 4. And so that's the extra step for problems like this. Now, there is still something else. Notice we don't have a beginning and an ending point or an interval that we're looking for solutions on. So we're looking for all possible solutions. So again, that infinite number of solutions. And so we're going to do the same trick that we've been doing before. We're going to add 2 pi times k, where k is going to be an integer. So it's going to be an element of the integers. And the same thing for our other solution, plus 2 pi times k. Again, k is an element of the integers. And the reason we had 2 pi times k, in case you haven't seen the other videos covering this, essentially k is just going to be an integer, so a whole number, positive or negative or 0. And every time you multiply 2 pi by k, say 3 times 2 pi, that just means you're going around the unit circle 3 times. And so you end up, after 1 2 pi, you end up right where you started, just with a new angle, but it's coterminal, so the same x and y values for the terminal point. If you added another, you would end up at the same place, and another, and you could continue doing that forever. And so this is how we cover all of the possible values. And so now, what we can do to solve for x is we can just divide everything by 4. And so that means dividing the 4x by 4, the pi over 3 by 4, and the 2 pi times k by 4. And we're going to do that on both of our solution sets. And so now I'm going to bring each of these down here separately. So for the first one, we now, of course, on the left-hand side just have x, and that's what we're interested in solving for. That's going to be equal to pi over 3 divided by 4. You could set up 4 as 4 over 1 and multiply by the reciprocal of the denominator since you have a fraction over a fraction. Either way, that's going to give you pi over 12. And we're going to add that to the 2 pi times k in the numerator divided by 4. Of course, the 2 and the 4 will cancel out, leaving you a 2 in the denominator. So that'll give us pi times k over 2. And that, again, is for all k element of the integers. And so that's the first solution set. That's the infinite number of solutions we get that are going to end in the same place as the original pi over 3. But again, we modified that. Now let's do the same thing for our second solution set. So again, 4k divided by 4 is just going to be x. 4x divided by 4 is just going to be x. And then 4 pi over 3 divided by 4 is going to give you pi over 3. Because again, you could think of it as 4 pi over 3 divided by 4 over 1. Dividing fractions means you multiply by the reciprocal of the denominator, and then the 4's would cancel. And the same thing is going to happen with the 2 pi k divided by 4. You're just going to get pi times k divided by 2. And that's going to be, again, for all k element of the integers. And so there we are. There is our solution set for this problem. So anytime you're dealing with tangent, it has its own special challenges. We discussed that. But anytime you have something multiplied by the argument, for instance, in this case, 4 times x, or in another problem, if you had 2 times theta inside of the trig function, that presents its own unique problem as well, where you have to set up, in this case, 4x equal to all of our possibilities and divide by 4 to solve for x.